All right, hello everyone. If you're tuning into this video, unfortunately you may have encountered the three flashing red lights, which indicates a thermal overload or thermal error from your Tesla wall connector. So I encountered this problem myself when I recently purchased a Tesla. A few months ago, I purchased some wall connectors, two of them, one for my shop, one for my garage, from eBay, thinking I'd save some money, and turned into be a little more of a project than I wanted. So one of them worked perfectly. Supposedly, according to Tesla, once I couldn't register it, told me that it had been replaced due to a warranty issue. The other one I didn't even ask him about, but that was the one that was giving me the flashing three red lights. So when investigating it, when it first happened, it would the three red lights would happen, and it would reduce charging ampacity down to 6 amps for safety reasons, and it would stay there until you reset it. So I downloaded a handy app called Wall Monitor, and Wall Monitor, if you know the IP address of your wall connector, you can put this app on your same network, same Wi-Fi network that your wall connector is on, and it will give you some readings. So I was able to do this, and as you can see here, it was showing 491 degrees Fahrenheit. And this happened when it was connected to the vehicle. Obviously, I took the connector out. I felt of it, it was not 491 degrees Fahrenheit. Reset the wall connector, tried that, did a firmware upgrade, all the things. Plugged it back up, got the same issue. Just it was kind of random. So there was no rhyme or reason to it. It also happened, and this is what triggered me to start investigating further, when the wall connector was not even in use. It would say I could connect this app and it would say it's 491 degrees Fahrenheit when it was not even in use. So obviously there was a problem with the thermistor or the circuit that was reading the thermistor. So that leads us here. So if you happen to have been dumb like me and bought a wall connector off of eBay that probably was replaced under warranty at some point because it had an issue, or you happen to own one that happens to be out of warranty and you don't want to replace the whole thing and you just want to replace the faulty thermistor, this video is for you. So in short, the thermistor in the Tesla wall connector is not replaceable. So I cut into this one just to see and reverse engineer. And it's full of all this potting material that you can see here. And it's a very dense potting material. It's not like caulk or something else. It's some kind of epoxy type material, and that's what makes the connector so heavy. So I did a little reverse engineering, was able to, and obviously there's some drawings out there that show the proximity pin and the control pin, or control pilot, proximity pilot. Earth is here, and then line 1 and 2 here, or your 240 or 208, whatever you may have. So try to identify all of these wires and reverse engineer some of it. So obviously this yellow and green one is protective earth or ground. The blue one, the large blue one here, and the large brown one here are your 240 or 208, whatever your service may be. I'll get into these other 4 small ones shortly. The orange, the blue, the white, and the purple. I have all those documented, what they are. But basically the whole reason I'm doing this video is to show you, because I haven't seen one online that tells you how to do this. So up till now, basically you have to, if you get this same problem, you have to throw your Tesla wall charger away or wall connector away and get a new one. I found a replacement wall handle on a place called Feyree.com, Feyree.com, and it comes, it's a NASC connector. It has all the pins in it. I've taken all the screws out. There's several screws that hold this thing together. But it has a waterproof connector port here. It has the push button, here the click, and it's got all the pins. So I can actually pull this out, and this contains all of the hardware. The other two main pins are still in there, or still connectors. Then this is the remaining control pilot, proximity pilot, and grounding connector. So this little connector here cost roughly $55, I think, when I bought it from the website. It also has inside of it, you can kind of see it there, there is a control board that has the button mechanism, and that is Tesla compatible according to their literature, and we're going to test it out to make sure it is. But I have worked out through some troubleshooting, because it doesn't come with any sort of directions whatsoever on how to connect everything up. It just, when you get the box, it just comes with this and all this. So that's what this video is for, is to show you how to cut the end off of your Tesla NESC charger and to hook one of these up. And if you happen to have a old out of warranty Tesla Gen 3 charger, then this will show you how to fix it for about $55, $60. Now there are some specialty kind of tools you're going to need that are, as far as crimping goes. There are some other ways around it. You can solder if you use a plumbing torch and things of that nature, and we'll discuss that here in a bit. But the whole point of this is just to tell you that you can fix your existing ESVE equipment if you want to for roughly $60 instead of trashing it and getting a hold of it. But the main thing is, first you need to troubleshoot it and make sure you're getting this open circuit error, this 491 degrees Fahrenheit. If you're not getting that, if you're getting something else erratic, but you need to confirm that it is your thermistor that's bad. Now, one thing I did learn in the process of this is there is no thermistor in this particular handle that comes from Feyree, F-E-Y-R-E-E. So, doing some research, found you can get on Amazon and buy these 10K thermistors for like $7 for 20 of them. So what we're going to do is we're going to epoxy this in the end of this new connector. So we're going to put this guy in here like so, and epoxy it between those two, line 1 and line 2. Then we're going to heat shrink these little individual leads, and I'm going to go through a step-by-step process of how to actually replace this handle, things you need to look for, and make sure you do it in order, because once you crimp these connectors, you cannot undo it because they have to go through this particular device here. So once you have to put your conductor through there, and once you put your conductor through there and you crimp it, it can only go back in there, and your crimping tool also has to be able to get over the top of what you're crimping. So there's 2 crimping tools I'll be using for this particular project. One's a hydraulic one, one's a hexagonal crimping tool. So just to give you a quick background on myself, I'm an electrical engineer. I work in the power space. I design substations for a living. However, I've always had a passion for electric vehicles and for projects. So I graduated from Western Kentucky University and Bowling Green University, and I was a sponsor of several projects in the first probably 10 years after I graduated. In 2011, I owned a Nissan Leaf, which is one of the first owners of a Nissan Leaf in the state of Tennessee. And one of the issues that I had was there was no mobile charger that you could change the connector on and change whether it was 120 or 240 or 208 or any of those things. So I tasked the engineering school with allowing me to sponsor a project with some students, and we developed a level 2 ESVE charger of our own, which is now basically what the Tesla mobile charger is. And just for the fun of it, we built this in 2011, and as you can see, this is a J1772 connector. This is where all the electronics and stuff are stored, and we have this interchangeable umbilical here, and that allowed us to, currently it's got a 120 on it, but we could change that out to a 208 or a 240 depending on the plug. We actually had some intelligence built in there where I mean, it was a standard NEMA plug, but we put some contacts in there with some resistors to, when you connected a umbilical onto that, it would actually tell the microprocessor inside that gray box the type of connector that was installed, and that would tell it, that would assume the current rating that it could utilize, and that would communicate that to the vehicle through pulse width modulation, which is part of that J1772 standard. So long story short is I'm very familiar with the standard in electric vehicle equipment charging and things of that nature. So we'll get into it. It's not a very long process. It's really more diagnosing and making sure that this is the issue that you have. If you don't have any electrical experience, I don't recommend doing this. It's not extremely difficult, but there is a lot of things that if you don't get the crimps right and things of that nature, things can be go bad. So anyway, we'll get into it here shortly, and you'll actually see me build the connector, this guy, from the ground up with my what's left of my cable from my Tesla Gen 3 wall connector. Okay, so we have successfully replaced the handle on my Tesla charger. I wanted to make one update before you get too deep in the video. This is the latest schematic here, and the one big change here is that the orange and blue wire I had swapped somehow. I'm not exactly sure. When I originally took voltage measurements, I would have sworn that the orange wire had 12 volts on it and not the blue wire. So the blue wire is actually the proximity pilot, and it's utilized to power the circuit board that's inside the handle. So we're going to go ahead and let you guys know that before you get too deep into the video to show step by step how to do it. But the line 1, line 2, which are the blue and brown larger wires, the protective earth, and then the control pilot wire are the 4 that actually go directly to the pins, whereas the blue wire will power the circuit board that's inside the handle. It has 3 wires coming off of it. One is 5 volts, which will connect to the blue wire that powers the board. Then you have protective earth, which is a jumper that I tied over to the ground wire with the protective earth wire. And then you have the output of that board, which is the will go to the proximity pilot pin. And so those 3 connections are made inside the handle. Protective earth also goes to the one side of the thermistor. The handle itself did not have a thermistor in it, so I got on Amazon, found a 10K thermistor, and for like $7 you get like 20 of them because they're so cheap and they're made out of nothing. But I do show how we connected that. Since it has 2 leads on it, we had to put some heat shrink on it to keep those from shorting themselves out, and then we epoxied it in between L1 and L2, which I also showed the video. And then the white wire, which is in the cable as well, goes to the other side of the thermistor to measure that. So all in all, just wanted to preface the entire video with this schematic and say that during the video, I do connect the orange wire to this board instead of the blue wire, and we discovered that it would not charge the vehicle. It said charge equipment not recognized, and whenever I put a voltmeter on the proximity pilot pin, I had no voltage. And then when I checked the white wire or the blue wire, it did have 12 volts on it, which is standard whenever it's not connected to a vehicle. So after knowing that, I swapped those 2 and everything worked perfectly. So just wanted to start there. All right. So now that we have chopped off our NACS cable, and we're going to put this Feyree, F-E-Y-R-E-E connector on. Here's the wires that are inside the cable. So these are identified. This is a Gen 3 charger. The large blue is line 1 and or line 2. Either way, it doesn't matter with 240. Brown is the other side, line 2, so 2 hots, hot. The yellow with the green stripe here is protective earth or ground. And then you have purple, orange, white, and blue for the small ones. So because this connector is slightly different, the blue wire will actually not be used. So we will actually heat shrink or tape that off, cut it off, and let it be. The orange wire is the proximity pilot wire, and then the purple wire is the control pilot. And then the white wire here is actually our thermistor reading. So one thing that we discovered when ordering this connector was that it has a push button, and it's got a little board inside of here that utilizes the push button. I thought that that might have a thermistor on it, but it does not. It actually is just the push button. So the rest of these are, the rest of the pins are inside this connector. There's a bunch of screws that I'll show later that you have to take out. And I can't get this sucker out right now, but you have your line 1, line 2, and then your 3 protective earth is in there, and then your 2 control pilot, proximity pilot pins that are in there. And we will crimp those. And I think due to the size, we're going to have to tin them in order to make them fit and get a good crimp on them. So we will go from there. All right, so what we've done here is I've put 2 jumpers on the protective earth. One of these is going to go into the handle for the push button, and the other one's going to be 5 volts. Or no, sorry. This will be the other side of the thermistor. So what we're doing now is I'm not going to crimp the protective earth yet because I want to make sure that it has the correct length to clip in. Once I do I may have to clip it off a little bit because of the way it sits versus the way these line 1, line 2 pins sit. So what I'm going to do now is use the hydraulic crimper here, and we'll place it in here. If I can get a hold of it and keep this on there. Okay, here we go. Hey Jace, do me a favor. Put your finger on the tip of this connector and just push it down against me. Give me some pressure. Okay. Okay, I should have it. All right. Well, that's a pretty good crimp right there. What we're going to do is we're going to actually hit it again on a different side here, just to make sure it is a good crimp. Probably should turn the hydraulic valve on. That's good and crimped. Now we're going to do line 2 here.
Dad, do you need this pin yet?
Not that one. That will be next. Same drill here. I'm gonna need your help to put some pressure on the pin. Just push it on the wire. So push against me. There you go. Now probably should turn the valve on. All right, let's try it again. All right.
I'm sorry, I wasn't looking.
That's not your fault. All right, here we go. good for video purposes, but it works great for me being able to see it. And as I was afraid of, that one's actually kind of loose. What we're going to do here is we're going to change our dies out. We're going to go to a smaller die. We're going to go to an 8mm die instead of a 10mm die. So we're going to do that real quick and recrimp these, and we'll come back. Okay, what we did here was we actually just, instead of tinning all the way around these wires, we just tinned a single side of them. If you tin all the way around, you're probably not going to be able to get these inside this connector. I even tried following up the tinning with crimping it with this to try to help round it off a little bit, and that didn't work either. So you just want to tin like one side, just one little strip of solder to help give you some filler, and that will make the connector tight enough to make your connections. So here's the trick too. We have to, at this point, place all our wires that are going through this guy. So you want to make sure it's facing the correct direction. So the smaller face will be going towards the inside of the connector. So what we're going to do there is we're going to slide our line 1, line 2 connectors yeah, with the face down like so. And then we also, the only other wire that's making it all the way through is the, let's see here, proximity pilot, which that is, or the protective earth, but that actually just clamps in here, so we're not too concerned about that. But one of the signal wires actually makes it through, and that is the control pilot, which is purple. And the control pilot goes on this. If you're looking at the connector this way, it's this right hole right here. Now, the protective earth comes around here and we'll go clip into the other lead, so we're not worried about that. The orange is the proximity pilot, and that actually goes to this board. So once we slide the rest of the connector on, we will connect this to one of the red wires. It has the red wire plus it's got a pin tied to the protective earth, and then out of that will come the wire that actually goes to this pin. So we've got a jumper for all those. So I'm gonna have 2 jumpers on this protective earth pin. But for now, what we're gonna go ahead and do is go ahead and crimp these 2 main connectors on here, and that will allow us to start working the other way. Okay, so we're going to, see if I can tilt this down a little bit more. We'll loosen this guy up. Actually, just straight remove it. This is the strain relief for the cable. I'll take that off for now. And we're going to slide this over the cable itself. All right, the rest of this will just kind of clip on, so I'm not too concerned about that. And then we have to work our way backwards through the cable here. So what you're going to want to do is go ahead and slide the entire body of the connector down over the cable. This is pulling all my wires out. Give yourself plenty of slack. We do not want to break any of these wires off their pads. So what we're going to do here is push these back down on the side of there. Try to get them back out. This is becoming more of a problem than it should be. What we're going to do now is we're going to try to slide this in there without bothering these 3 little wires. And then one of these wires actually hits the protective earth in here, but instead of trying to bend it around backwards, what I'm going to do is actually just solder a jumper to the protective earth and slide it down through it so that it's just a simpler connection. And it's just a signal wire, so there's no current carrying or anything like that, so it doesn't really matter. Okay, this is a lot harder than it should be. I'll probably edit this out. No, I don't need help, Jace. I need it to quit trying to grab these small wires. That's what I need it to do. There we go. All right. So I gave myself plenty of working room. Now we're gonna slice the cable back. So I guess at this point, it's probably a good idea to review what tools you need. Obviously you need a knife. You need yourself probably a good soldering iron if you're going to end up tinning or soldering some of these wires together. Good idea to have some heat shrink, a couple different sizes. For the thermistor, you need some really small heat shrink. I've got the hydraulic crimping tool for the line 1, line 2, and protective earth or ground connectors. I have this ratcheting, which I'll use for the smaller, the proximity pin and the control pilot, proximity pilot and control pilot conductors, and then obviously your good set of wire strippers. So, and then you will also need, I'm not exactly sure what size this bit is. I'm actually using a Torx bit, even though that's incorrect. The connector itself actually is a hex key, and I'm not exactly sure what size it is. I'm assuming it's metric. If it is, it's very small, and I don't happen to have it. This just happened to fit it right. I know in standard it's smaller than 3/32, so it's a very small head. And then obviously for your heat shrink, you need a heat shrink gun. So with that said, we will move on here. I will also kind of show my schematic that I have drawn out here. This shows line 1, line 2, or the blue and the brown wire, big. The white goes to the thermistor. That's the thermistor right there. The other side of the thermistor goes to the proximity or the protective earth pin or ground. Proximity pilot actually goes to this little board that's inside the connector, and that is these 3 red wires that are inside of here that come out here represent these 3 wires, 1, 2, and 3 here. And so it actually will feed off, it will take in the proximity pilot wire. The orange will actually connect to one of the red wires on this board that says 5 volts in. Then the protective earth will connect to the PE connector. So on the PE connector, whenever I crimp it, I'll have 3 wires. I'll have the main yellow and green, and then I'll have 2 jumpers that I'm going to slide in there. One will go to the thermistor, one will go to this board. And then coming out of the board is another red wire that is it's labeled PP on the board. It will come out and actually go to the proximity pilot pin. So that pretty much covers everything. Like I said, the only thing we're adding here is this thermistor. We're just gonna epoxy it into the end of it, and it goes to the white wire with the other side connected to protective earth. So now we got to give ourselves some working room. You can cut off the strain relief fiber there. All right, so now we got a good little spread here of the conductors. I'm gonna have to give myself a little bit more of the ground, line 1 and line 2. I'm not exactly sure what gauge these are. My strippers only go down to 12 gauge. I'm gonna guess these are probably, 8 gauge. But I have running to the charger, as you can see, my power panel's right here. I originally had a generator outlet. There was a 30 amp outlet and I was using the mobile charger for that. I ended up cutting the drywall out and putting a 6 gauge, 6.2 with ground over here to where the charger was. I intended to put a generator outlet there, a 50 amp, and reutilize it, just use that for charging most of the time, and then backfeed my panel if I ever needed to use the generator. And unfortunately, I forgot that it did not have ground, and to use a generator, you have to have that. So now it's just a hardwire charger, and I'm going to end up replacing my panels, what I'm going to do, because I already have a bunch of twin breakers and stuff in there anyway. This is not my main power panel, it's just the power panel for the house. I actually have a 400 amp service or two 200 amp services, and this is a sub panel off of one of the 200 amp panels on the side of my house over by my actual meter. All right, so for the ground wire, if we look at this here, it's kind of loose. So there's a lot of room in there, and that being the case, what I'd like to do is tin this wire so I get a little more meat on it before I try to crimp it. The other option is to try to fill this full of solder. That'd be really, really tough. You also have these rubber grommets, you'd have to take that off. And yeah, you'd have to have like a plumbing torch and really work on it. You'd probably end up melting some of the wire if you did that. Even if you just got this really hot, started filling it, and then tried to insert the wire in there, I mean, you might end up with a cold solder joint. It wouldn't work very well. So what we're gonna do, this is also gonna be the case for line 1 and line 2. These do come out of here. Let's see if I can push one out. So the line 1, line 2, that's a pretty good size connector, as you can see. But when inserting the wire into there, I mean, it's a decent fit, but there's still a little bit of room in there. So what we're gonna do is we're going to tin this as well. And that way it gives a little more meat on the bone, and then we'll crimp that with the hydraulic crimper. Once again, I could crimp that with these, however, the connector will not slide through there. So once I crimp it onto the wire, I'd be stuck. So if I were to do this here, now I'm just stuck on the wire itself. I can't get this thing off. So that's why we're gonna use a hydraulic crimper and go from there. So instead of boring you guys, I'm going to tin these real quick and we'll come back. Okay, so it looks like I finally got this thing out. This is what it looks like. So your proximity pilot and control pilot pins actually just sit inside of here, whereas the protective earth actually slides in there. So the issue here is whatever you're going to use to crimp, you have to slide the wire through first, make the crimp, and then it has to be able to come off of that pin. So where is the, for example, for the smaller connectors, we're going to be utilizing this tool right here. So if I slide the wire up on it and I make the crimp, I need to be able for this piece to come all the way through so I can get it off the wire itself. Whereas these larger line 1, line 2, this tool will not work for those. So for those tools, or for those pins, we'll be using a hydraulic crimping tool. And that allows us, it doesn't actually go all the way around it, so it will allow us to be able to come off of the connector. It doesn't have to actually slide over, although there is plenty of room to slide over. And so since it did not have a thermistor, you have two options. You can either jumper a 10 kilo ohm resistor back in the actual base station here, which actually removes your safety feature of measuring the temperature inside the connector, and it will think it's 70 something degrees all the time. Your other option is to get on Amazon, and for $7 you can buy 20 of these 10K NST thermistors, and they actually work perfect. I tried it out, just touching it to the wires here, and it measured basically my body temperature. And then when I let it go, it ran down to ambient temperature. So problem I had was I was reading 491 degrees Fahrenheit on occasion, a lot of times whenever the connector was not even connected to a vehicle. So I knew it was a thermistor problem, or there's something going on inside the cable, or when it attached, or the measuring circuit on the actual charger itself. So taking a gamble to replace the handle itself, all because of this little guy. This 20-cent part or 10-cent part is actually what caused my entire system to fail, and that's why now with a $50 handle, I'm going to replace that. So what we're going to end up doing is we're going to solder some wires to this, and then heat shrink the leads, and then we will epoxy it up inside of here so that we are getting a decent temperature reading between the two terminals. So I do have a handy dandy list here of all of the things that I need to do. So step one is to download the wall monitor app. Make sure that you're getting a 491 degree Fahrenheit reading. That means that you are reading an open circuit and you have an issue with your thermistor, or at least the measuring circuit or something inside the cable. Obviously, go ahead and procure the replacement handle. Make sure you can get that in the thermistors. At that point, you cut off the connector, verify the pin out by ohming out the existing or the previous connector. And then we need to start assembling the connector. So we got to start backwards. So we're going to start with the rubber grommet sliding onto the cable. So we're going to take this guy apart here. All the screws are already out of it. So this has to go on first. Obviously, make sure your power is off when you're doing this. Okay, so we've crimped line 1 and line 2. I ended up having to go down to an 8mm crimp die on the hydraulic crimper. You can get that from Amazon. I bought it for, I think it was like $50 or something like that. But what I was worried about was this the protective earth wire being slightly different than the line 1, line 2. And it looks like if you clip them all the same length, they're going to fit just perfectly. So I haven't crimped this one yet. So I'm going to, instead of using the hydraulic crimper, I'm just going to use my hexagonal crimpers here, because this will slide over. Oh, and that did not even bend. It just put markings on this ferrule. So we are going to go to the hydraulic crimper. So with that being said, we will load a new die up and we will crimp this and we'll be back. Okay, so we went to crimp this with the hydraulic crimper and we broke the back side of this connector off. So it is still have a good crimp, believe it or not. Oh, no, it just moved. So we are now down to, we're going to have to solder this sucker together. So we're going to spend some time doing that real quick and then we will come back. Okay, so to help this connection out, what we're going to do is we're going to slide a piece of heat shrink on here. The ground conductor here actually doesn't carry any current at all. It's only used for fault detection and then also for signal reference. So it's literally just the grounding wire for signals. So what we're going to do is slide a piece of heat shrink on here that will help maintain this connection after we solder it, since it decided to break on us in the crimp. So we'll slide this over the wires here, and then we're going to now solder this sucker together. So that's going to take a minute. It's going to be awkward, so I'm not going to video this, but just know that we're taking the soldering iron down here on the ground, and we are going to solder the sucker together. Okay, we have now come back, and this was actually a lot freaking harder than it looks, and we have this beautiful, disgusting solder job here. But it is solid. So we're going to slide the heat shrink above that, and we're going to get this guy ready to go into the connector here. And then after that, we're down to signal wires, and we'll come back to that in just a second. Okay, we're now at the point, we got the two L1, L2, and the protective earth all crimped and or soldered together. I've got my two jumpers here. One of these is going to be for the little control board that's inside the handle here itself. So it's actually going to go to one of these little red wires down here. And then the other one's going to go to the other side of the thermistor, which I've yet to put in. That'll be one of the last things I do. But we're now, the only other wire that actually makes it all the way through the connector is the control pilot wire, which is purple.
Where are the true connectors?
So we have to, looking at the connector this way, that is going to slide through here, and we're going to crimp that guy on and then come back. All right, so this thing does not have the force required to crunch these connectors here. So what we ended up doing was taking the hydraulic crimper, and I just placed the pin in the flat part of the crimper here on the side and just squished it. So that was the way I was able to get my crimp on that, and that's how I wanted to end up doing the rest of these. This thing is basically useless for this project, so do not get one of these and save yourself $30 or $40. Just get the hydraulic crimper for like $50 and you'll be set. So now moving forward, what we've got here is the blue wire is now decommissioned. We've got the orange wire and the white wire to hook up. So the orange wire is going to power our PCB board that's inside this handle, which deals with the push button here to release and unlock the charging handle. The white wire is our thermistor reading, and then these two jumpers here, one's going to go to the board down here, and one is going to go to the thermistor, which we will do here momentarily and solder into, or epoxy into place here. So may actually do that first and go ahead and get that out of the way where we can, while we still got some movement. And then the last thing we'll do is connect these two wires down here to the this board here, and then we'll assemble the whole thing and see what happens. All right, so here's kind of the hard part. With the cable in here, we have to get in here and identify these wires that are on here. So the 5 volts is the far right one here, I'm pretty positive. Yeah, you can't see it in this video, but it says 5V right there. And then the other two, there is one called WD, that's for testing, which is not utilized. It's not a pad that's being used for anything. And then, like I said, the hard part here is actually getting these wires separated and making sure that you have the correct wire down here in the bottom of the handle, because we're about to make these connections. So I'm trying to do that now. And I should have written down how they go in order, but from top to bottom it goes, or right to left I should say, it goes 5 volts, WD, protective earth, and then proximity pilot. So 5 volts, WD, protective earth, proximity pilot, right to left, looking at it straight on. So just make sure that you have those. So what we're going to end up doing is one of these jumpers here, we're going to take down and solder to the protective earth, and then the orange wire here, we're going to pull one of these jumpers, actually going to create a jumper down here and run it up to this orange wire, and that's going to supply the proximity pilot circuit inside the handle here, and then coming out will be the last jumper that we need on this. Now that we got the purple wire hooked up here, it'll be the last one coming out of this connector. So do that here in just a second and get back to you. Okay, so now what we've done here, we've heat shrinked off the blue wire because that's not needed. The orange wire, we heat shrink down to a jumper that comes out down here in the bottom of the connector, and we're going to connect that to one of these three other little red wires that are down here, which are connected to the circuit board that's in the handle, which deals with the push button. So what I'm going to do next is, and then the next thing after that, so I'm going to go ahead and connect these down here first. So I'm going to end up making this connection, which will be the orange wire is going to go to looks like the 5-volt pin on the board, which is this one over here. It's one on the far right, as I told you guys earlier. And then the protective earth is the second jumper I have down here. So I've actually got 2 wires down here. That one I need to dig out. Let's see here. Okay, so this is actually the orange wire right here. This is the protective earth jumper. And then what I have to do is I need to make another jumper to go back up here and become the proximity pilot. So what I'm going to do is take the last pin that I have, wherever it may be. I've got 4 of the 5 connected right now. I'm going to put a jumper on it, run it back down to the handle, and then I'm going to make all these lower connections here. And then once I'm done with that, then the last thing I'll do is put the thermistor in, and we'll go from there. Okay, what we've done here is this last connection. I mean, I've got some really small wire, which these are signal wires. This is like 22 gauge, maybe. I just went ahead, instead of trying to crimp this one, I just filled it up with a solder, basically filled the solder well up. So with that, what we're gonna do now is we're gonna come back through our little connector here, and we'll slide the last of our 5th wire here through into that, and that basically makes up the connector end. Oh, we got an issue here. There's too much solder sticking out there. I'm gonna have to suck that off. That's keeping it from getting the connector. So let's try to wipe that off real quick. There's the soldering iron. Just trying to smooth this out here. I don't want to have to go get my solder sucker out of the shop because it's a little ways away, and that is getting really hot, as you can imagine. Smooth this solder out here. I'm not exactly sure what the clearance is inside that plastic piece. If I can pull this and just get it to lay down, maybe that will be enough. Not have any rough edges. Let's get that shot, let it cool off in a second. Still pretty dadgum hot. But let's see if it fits. So here we go. And it still does not appear to want to fit the way it should. Actually, neither of these do. The crimped one or the soldered one. Huh. And that one really didn't want to go down in there. We're going to have to do something about that. To make all these things seat properly. But yeah, that's going to be an issue. So crunching that one flat caused a problem there. This one being soldered appears to work just fine. L1, L2 appear to be just fine. Ground appears to be just fine. Protective earth, whatever you want to call it. So all those look good except for this purple wire here, which since I crushed it flat, does not want to seat properly inside the little thing here. So what I'm gonna have to do is re-crimp that and make it more cylindrical. So what we've got left here is we've got this wire, which is connected to the proximity pin. Proximity pilot is what it's called. And then we have what needs to be connected to protective earth or ground. And then we have this conductor here, which will serve as the 5 volts to the circuit board. So all three of these wires go to the circuit board itself. Something smells like it's on fire. Three of these go to the circuit board itself, and then one of these goes to the thermistor. So one of these jumpers goes up here, thermistor, so we'll do that one, and then the rest of these three go down here and connect to these 3 wires in the end of the handle. So we're gonna do those one by one, and then the last thing we'll do is solder in the thermistor or epoxy in the thermistor, and then we'll assemble the whole cable. So as of right now, I'm sitting at about 2 hours, which I'm going extremely slow, making sure I get this right. But I would anticipate taking your time on this to make sure that you don't mess it up. All right, so what we got here is I took one of the protective earth wires here and just twisted it over with the white wire for the thermistor, so they're kind of out of my way. These other 3 wires, one is protective earth, which is going to go to the IC board. One is the proximity pilot pin, which is going to the output of the IC board. And then the orange wire is the plus 5 volts. It's going to power the IC board. So all 3 of these wires are now going to go down here into through the handle. And here's going to be the hard part, is keeping these wires separated from the other wires and understanding what they all are, because they're all red. So what I'm probably going to do real quick is sit here. I'm not going to put this on camera, but I'm going to go through here and actually tape these wires off so that I know what is what. And then that way when I make the connections, I'm not worried about what is connected to what. So I'm going to do that real quick, and then we will come back to soldering. Well, you guys don't want to see me solder together. So once it's soldered together, I'll show you guys it's soldered together, and then we'll put the thermistor in. We'll show that, and then reassemble the connector and test it out and make sure that it fires up, and then plug it in the car, see what happens. Okay, now we're down to the last couple of connections. I've got the protective earth from the IC board inside the handle, which deals with the push button right there. And now I'm twisting it together with the jumper that came from the protective earth up here in this pin. I've got 2 jumpers off of it. And the last 2 wires I've got here are the proximity pilot. This is the output pin. So this is actually a jumper. This one is a jumper from, up here on the proximity pilot pin, and it comes down here, and we're going to connect it to this other wire, which is the output of the little IC board that's inside the handle. So once I get those two going, we're effectively done outside the thermistor. So I'm going to twist these two together and then solder them and heat shrink them. That is not a very good job. Let's see if we can redo that here. Okay. Jason, you want to solder these for me real quick? A little bit more. I mean, don't wipe it, just hold it on there. You're going to flick it on my hand is what you're going to do. Just hold it and put the solder on it and slowly move it. There you go. Okay. So now we're going to heat shrink these, and we should be done outside of hooking this thermistor up. And like I said, the thermistors, we're going to epoxy into place. So I got to get a epoxy tray out and mix some, and we're going to solder it or epoxy it right in here in between L1 and L2. And that should basically complete the whole thing. I mean, then we're gonna fire it up, put the connector together, and then fire it up and see, obviously if the charger or the wall connector is operating properly, and then we'll plug it up to my vehicle, see what happens. Okay, we're down to the final piece here. So we got this little thermistor. We're going to epoxy in between L1 and L2 here. But the first thing we have to do is the only two wires we have left, which go to the thermistor, is this protective earth and the white wire. So what we're going to do is got my handyman here, cut me some heat shrink. We're going to slide this over the white wire. Here, Jace, why don't you come try to do this while I'm holding this here. If you can try to straighten that out, put that on there. Okay, and then you put one on that. You have to twist the end. And obviously what we're going to do is we're going to slide that heat shrink up onto the leads because you don't want that to short out. So that's the goal here. Slide that all the way down. We're going to want that the same length as the white wire, so you're going to want to get the cutters and cut that off.
Cut what off? Oh, the wire.
The rest of the red wire. Cut it off like right there. Okay, we're gonna strip it. Okay. So we're gonna solder these two. It does not matter which side goes to what. It is bisexual, as you say. Doesn't really care. So we'll solder those two wires to this and heat shrink them together, and then we'll epoxy that. We'll show you what that looks like in there, and then we'll see if this thing even works when we fire it up. Okay, we now have the thermistor soldered in, and we're about to heat shrink it up. You need to wiggle the plug down there. Close it down here. Okay. All right, and now we're going to mix up some epoxy, and we're going to place this dude right in there, in between these two L1 and L2. So we're going to mix some epoxy, get that to go in there and set that up, and then we will come back and reassemble the entire connector. Okay, so now what we've done here is we heat shrinked up our thermistor. We epoxied it into place here in between L1 and L2. All the other wires are connected. We are in happy shape here. So we're going to now again try to assemble this connector. So the very end piece is here. It's got a weatherproof O-ring around it. And we're going to finagle all these little pins into place here. So they all need to be about, these 3 pins here need to be about the same height. And we will have fun fighting this for a minute. Okay, with all the wires connected, this is a little bit more difficult than it seems, but we finally got the conductors up into the end connector here. So what we're going to do is now make sure these don't slide around any of the studs in here that are used for assembly. Oh crap, just pulled that off, and that was what just took me about 5 minutes to get on here. Okay, there we go, not too bad. But basically, these screw studs that are in here, you don't want to get the wires overlapping that. So you just need to make sure they're pushed in the center of the body as you slowly, very slowly, no, as you slowly put this thing back together. And there we go. All right, so now we have 2 screws. I have a magnetic tray somewhere that has the screws in it. And there's 2 screws that go in the very end here. Let's see if I can focus in there. There's 1 on each side. So you can kind of see the screw holes there. There we go. 1 on each side. So we're going to replace these screws in there. That actually ties these 2 pieces together, and then we'll put the strain relief on down here at the end of the cable. So one thing I won't mention, when you strip, I should have probably mentioned this at the beginning, when you strip this, you don't want to do more than like 5 or so inches. That way you don't end up with, you can see here, I did about 5 inches, and I am very close to having cable, you know, exposed here. So you don't want to go more than probably 4 or 5 inches. Otherwise you'll end up having to put some heat shrink on here, and after the fact you can't really do that. Or you'll have to tape it up in order to keep this cable all sealed together. So I'm gonna find those screws and put those in, and then we'll come back. All right, so we've had to make a correction from the original wiring plan here. Thermistor appears to be good. The wall connector is now powered on. You can't see it here. Let's see if I can twist around here. No, you can't see it. It's behind the shelves. But here it is connected to the wall monitor app, and as you can see, the ambient temperature is good in the handle. The one change that we've had to make is that the blue wire, which I thought was not needed, is actually the correct wire to supply power to the proximity pin. I don't have my drawings or my diagram here. But instead of the orange wire is actually the one that does not need to be utilized. So what I did is I moved this blue wire over to the powering circuit, the 5-volt circuit inside the handle here. So 5-volt pad inside here goes to the orange wire. We're about to solder that, then we're going to heat shrink it, and then put the connector back together, and everything else should be great from there. But as I said, it goes to the 5-volt pad, which is over here. And so we'll go from there. All right, so we have finished the project. The major foobar that we had was somehow, I'm not exactly sure how, in my schematic that I had drawn up here, the orange wire I had pinned as the proximity pin, and for some reason, that was not the case. It's actually the blue wire. It had 12 volts on it, so when we plugged the connector in, initially it said charging equipment not recognize. So I took my voltmeter and checked from the ground wire to each of the proximity pilot and the control pilot, and I only had 12 volts on the control pilot, not the proximity pilot. So then I measured the blue wire and it had 12 volts on it. So once I swapped those, it powered up the board, and that's what powers this guy. Everything works just fine. So I hit the button, comes unlocked. If I hit the button on this now, opens charging port, insert, charger turns on, and the vehicle is charging. So all in all, $50 for a thermistor that was bad, and 2.5, maybe 3 hours of my time. Should have been less than that, but this is the first time doing it. Hopefully with this video, you'll be able to do it a little bit faster. So hopefully none of you guys have this problem, but if you do, feel free to message me, or hopefully this video takes care of all your questions.